Hello students, welcome to a new lecture of P block elements, in which in the previous classes we have seen D block elements, F block elements and coordination compounds formed by D block elements, right. Now the next block elements are P block elements, in which we are going to study about each and every group of that block individually, its properties and some of the elements belonging to that particular group, right. Now before going for that, let us look at how many groups are present in a P block, right. There are 6 groups starting from 3rd, 4th, because the first and second comes under S block element. So P block starts from 3rd group, 4th, 5th group, 6th group, 7th group and 8th group, right. So now in 3rd group who comes? Boron, carbon, nitrogen, oxygen, fluorine and neon. Boron family means all the elements coming in that group. Carbon family means all the elements coming under carbon. We have already studied in our first year. So from 5th group element, which is nitrogen family. What is nitrogen family? The group in which elements are followed after nitrogen. Therefore it is called as nitrogen family. From nitrogen family, oxygen family, halogens and inert gases. These 4 groups are coming under P block elements of 2nd year, right. So we will study about P block starting from this group, right, because this is already done in our first year syllabus, right. Now let us have a look at 5th group element. Who comes under 5th group elements? Nitrogen, phosphorus, arsenic, antimony and bismuth, right. These element comes under 5th group elements, right. What will be the electronic configuration of these group elements? NP1, NP2 and then NP3 will be for these groups, right. So specifically for these group elements, the electronic configuration is NS2 is already over for S block elements, right. Therefore you should not write NS1 to 2, you should write NS2 only, and NP3. If general electronic configuration for all of them is NS2 NP3, what is the electronic configuration of nitrogen? 2s2 2p3, for phosphorus 3s2 3p3, for arsenic 4s2 4p3, for antimony 5s2 5p3, for bismuth 6s2 6p3, right. So this is the electronic configurations of all of them, right. Now if electronic configuration is this, what is the other general properties of these group elements? Among general properties, the first general property is electronic configuration. The next general property is, in this group from top to bottom, what happens to atomic radius, what happens to ionization energy and what happens to electronegativity. If you know about atomic radius, the other two you can very easily write, right. Therefore let us write about atomic radius first, or atomic size, whatever can be written, right. From top to bottom, atomic radius increases, right, increases from top to bottom. If atomic radius increases from top to bottom, that means what happens to ionization energy? Decreases from top to bottom. Ionization energy decreases from top to bottom. If atomic radius increases from top to bottom, what happens to electronegativity? Even electronegativity also decreases from top to bottom. That means which element in that group has highest electronegativity? Is nitrogen. From nitrogen the electronegativity decreases, therefore nitrogen has the highest electronegativity. What happens to the nature? What happens to the nature of the element? Nitrogen and phosphorus is purely non-metal, arsenic is metalloid and antimony and bismuth are metals, right. So metallic nature also increases from top to bottom, in which nitrogen and phosphorus are non-metals, arsenic is semi-metal and antimony and bismuth are purely metals. These are that nature. The next important is oxidation states. Oxidation state means how many electrons can they lose or gain, that is called as oxidation state. If they lose one electron, the oxidation state on them will be +1. If they gain one electron, the oxidation state on them will be -1. Same way, if they lose two electrons, the oxidation state will be +2. If they gain two electrons, their oxidation state will be -2. These are nothing but oxidation state. We have to write the oxidation states of all the elements which are possible. So, all the possible oxidation states common for this group should be written here, right. So, for this group, the common oxidation state is -3, +3 and +5. -3 means this element can gain 3 more electrons. If they gain 3 more electrons, what happens to their shell? It becomes completely filled. Already 3 electrons are there. On top of that, if they gain 3 more electrons, it becomes NP6, which is a completely filled p orbital. Ns is already filled, Np also becomes filled. Total 6 plus 2 octet will be fully satisfied. Therefore, -3 oxidation state is possible for them. What is the next oxidation state? +3. What does it mean by +3? All the 3 electrons present in P can be lost. If that is lost, their oxidation state becomes +3. What does it mean by +5? 3 electrons of p orbital and 2 electrons of s orbital. Together 5 electrons which is present in the valence shell can be lost, and if that is so, their oxidation state becomes +5. So, all these 3 are possible. In these 3 also, which one oxidation state chances are more, which one oxidation state chances are less? When you say -3 oxidation state, it can be possible only by nitrogen. If you go down, getting -3 oxidation state becomes difficult, and only nitrogen can show that. Why? Because -3 means gaining 3 electrons. To gain 3 electrons, the electronegativity for them should be high. But out of all of them, whose electronegativity is high? Only nitrogen's electronegativity is high. Therefore, only nitrogen can easily gain 3 electrons, and from top to bottom, getting -3 oxidation state is not possible. Only nitrogen can show. Then comes +3. Between +3 and +5, the stability of +3 oxidation state increases from top to bottom. The stability of +5 oxidation state decreases from top to bottom. Why? Because losing 5 electrons from top to bottom becomes difficult because of inert pair effect of NS2. As you go down, what happens is the electrons present in NS2 shows inert pair, means they cannot be removed easily. That is called as inert pair which are present inside, right. If they cannot be removed easily for bottom elements, that means bottom elements cannot show +5. Top elements don't have that much inert pair effect, so top element can lose 5 electrons. Bottom elements cannot lose 5 electrons. Therefore, for -3 only nitrogen, for +3 bottom elements are preferred, and for +5 top elements are preferred. These are the oxidation states. These are general properties. Now, let us look at chemical properties, which means that these group elements, how they commonly react with hydrogen to form hydrides, how they commonly react with oxygen to form oxides, and how they commonly react with halogen to form halides. These are chemical properties which we will see. First, have a look at reaction with hydrogen. When they react with hydrogen, what do they form? Hydrides. If any element react with hydrogen, they form hydrides. Same way, reaction with oxygen. If any element react with oxygen, what do they form? They form oxides. Same way, if any element reacts with halogen, they form halides. How fifth group form hydrides, how fifth group form oxides, and how fifth group element forms halides, we have to study. Hydrides, fifth group element combines with hydrogen to form hydrides of the general formula this. NH3, PH3. Next is arsenic hydride. Next is antimony hydride. Next is bismuth hydride. Right? Nitrogen hydride with nitrogen, hydride with phosphorus, hydride with arsenic, antimony, bismuth. Hydride with nitrogen is called as what? What is the name of this molecule? It is a hydride, but its name is ammonia. It is also a hydride, but its name is phosphine. These are having metallic nature, so those names are not important for us, but all of them are hydrides of 15th group element. In this group element, what happens to the reducing nature, what happens to the acidic nature is, from top to bottom, hydrogen becomes more acidic on this element, therefore acidic nature changes from top to bottom. So what happens to the nature of hydride is, if you compare the nature of basic capacity or basic nature of these hydrides, what does it mean by basic nature? Is their ability to act as a base, which means lone pair of electrons has to be donated or protons has to be accepted. That nature is called as basic nature. Basic nature depends on electronegativity of the central element, right? But what is happening to electronegativity from top to bottom? It is getting decreased. Therefore, basic nature of these hydrides decreases from top to bottom, because basic nature depends on the central element. Whereas what happens to the reducing ability of these hydrides? Reducing ability means their ability to donate its hydrogen is called as reducing ability. Reducing ability increases from nitrogen to bismuth. Why? Because as the central element is more electronegative, its hydrogen cannot be donated easily. As the central element is less electronegative, its hydrogen can be donated easily. From top to bottom, reducing ability increases and basic ability or basic nature of the hydrides decreases. Right? This is about the reaction with hydrogen or hydrides. What is the general formula? MH3. What is M? M can be nitrogen, phosphorus, arsenic, antimony and bismuth. Going to the next nature, which is oxide. All the elements of this group can form oxides of the general type. What type of oxides do they generally form? M2O5 and M2O3. What is M? M can be, M2 can be N2, P2, arsenic 2, antimony 2 and bismuth 2 with oxygen. So they can form M2O5 type of oxide, that means pentaoxide, or M2O3 type of oxide, that means trioxide, right? So same way for, if they combine with oxides, which type of oxidation state will they have? Each oxygen has -2, right? -2 means -10, that means +5. Same way -6, that means +3. This type of oxidation states are possible, we have already seen, right? Where was it? Oxidation states. In oxidation state we have seen that the elements of this group shows oxidation state of +3 and +5. So for +5 oxidation state was, chances was decreasing or not? Chances of +5 oxidation state was decreasing. Therefore, pentaoxide capacity also from top to bottom decreases. Chances of +3 oxidation state was increasing. Therefore, trioxide making a trioxide chances are also increasing from top to bottom. You have to relate it with oxidation states, which we have already seen. We have seen that +5 oxidation state is easy for top elements, difficult for bottom elements. If that is the case, top elements can form pentaoxide, bottom elements cannot form pentaoxide. +3 oxidation state was easy for bottom elements, difficult for top elements. Therefore, trioxide of top elements are unstable, trioxide of bottom elements are stable, right? Now, going to the next is their reaction with halogens. If they react with halogens, they form halides. Which type of halide do they form? MX3, that means trihalide, or MX5, which means pentahalide. Which can you give one example of trihalide of nitrogen? NCl3, or I can say NF3 also, right? For trihalides of nitrogen, only NF3 is possible. Why? Because in a trihalide, electronegativity of halogen should be higher than the central element, and nitrogen's electronegativity is lower than fluorine only. All other halogens electronegativity is not lower than nitrogen, right? If you compare electronegativity of nitrogen and fluorine, nitrogen is less. If you compare electronegativity of nitrogen and the remaining halogens, nitrogen's is more. Central element cannot have more electronegativity. So, in trihalides and pentahalides of nitrogen, common is with fluorides only, right? But for phosphorus, both PCl3 and PCl5 are very common. PCl3 and PCl5, right? So, these are halides of these elements. Now, what we will see is each and every element has a certain special compounds. What is the first element of this group? Nitrogen. What are the special elements of nitrogen? We will see. Special elements of phosphorus, if any, we will see. Like that, all the special elements. For nitrogen, you can have dinitrogen, you can have ammonia, you can have oxides of nitrogen, you can have what else? Nitric acid, right? These are the compounds of nitrogen. What is the compound? Dinitrogen or nitrogen gas, ammonia, oxides of nitrogen, nitric acid. Next, what is the next element? Phosphorus. For phosphorus, its elements are white phosphorus, red phosphorus and black phosphorus, right? Black allotropes of phosphorus. These are one type of compound. The next type of compound is oxoacids of phosphorus. What is the next compound? Phosphine is the next compound, right? These are certain elements of phosphorus. So, we are going to study about each and every compound of a particular element. Let us start with nitrogen's element. What is the first element of nitrogen? Dinitrogen is the first element. So, the next compound, the first compound of nitrogen is dinitrogen. What is the formula of dinitrogen? N2. How is the dinitrogen molecule present? Dinitrogen is in this way. In that molecule, there is a triple bond between two nitrogens. There is a triple bond between two nitrogens. On each nitrogen, there is a lone pair. Lone pair. How many bonds it has? 3 bonds. That means this molecule is very much inert. It is very difficult to remove all the 3 bonds. Therefore, bond enthalpy of this molecule is very high. What does that mean? It means it is very difficult to remove these bonds in the molecule. If it is not able to remove the bonds of that molecule, that means it is also very difficult for the molecule to make react. That means it is not that much reactive compared to other molecules. It is inert in nature. If you want dinitrogen to react, you should always take higher temperatures in the reactions. That we will see now. So, let us study preparation of dinitrogen. How can you prepare dinitrogen from different compounds, right? We are going to see 3 or 4 preparations of dinitrogen, but in all of them you will take combination of salts or a single type of salts, but from salts only generally we will get dinitrogen, right? The first salt, the first preparation is ammonium chloride plus sodium nitrite. If you heat these two salts together, There is a nitrogen here, there is a nitrogen here. Nitrogen from this salt and nitrogen from this salt combines together to give you dinitrogen, which you want. Right? After that, the leftover is H2O and what's left? NaCl. How many H2Os? 4 hydrogens here. So 2 H2Os, 2 oxygen, everything is balanced, right? So this is the preparation in which you take 2 salts, one nitrogen from one salt, another nitrogen from another salt, at higher temperatures will be combining with each other to give you dinitrogen. In the next reaction, what I will do? I will take a single salt only, but it is a bit complex salt. Which salt? Ammonium dichromate. What we know potassium dichromate, right? K2Cr2O7. That means K plus. Like that 2 K plus ions are there. That is called as potassium dichromate. Instead of taking 2 K plus, if you take 2 NH4 plus, NH4 plus. There are 2 nitrogens. One nitrogen from here, another nitrogen from here. If you heat ammonium dichromate, nitrogen from 2 ammonium ions combines to give you dinitrogen along with water and chromic oxide. How many hydrogens? 4 2s are 8, right? So 4 2s are 8. How many oxygens? 4 oxygens. 4 plus 3, 7, right? Is it balanced or not? Yes. So this is one more method in which you are taking a single salt only, in which 2 nitrogens are already present. Once you heat, you will get dinitrogen and the remaining products are balanced. Right? That is one more method. Another method of preparation of dinitrogen is by taking barium azide. Right? This is barium azide formula. On each azide, barium comes under second group, right? Comes under calcium group. Calcium, magnesium, barium, strontium, radium, right? So on barium plus 2 oxidation state comes, which you already know. That means here what should be the oxidation state? -2. How can you get -2? But on this azide, it is barium azide. On one N3, the charge is -1. That means on another N3, another -1. Total how many you have to take? Azide means 2 N3s, right? Don't count its nitrogens now. You just balance the charge and don't take just BaN3. N3 is taken 2 times, barium is taken only 1 time, because on each barium +2, on each azide -1 2 times. So when you take barium azide and heat, barium azide is also one salt, a single salt. How many nitrogens can you see? So many nitrogens, right? So you don't need any other salt, just a single salt. When heated at high temperatures, what you will get is dinitrogen. How many nitrogens are here? 3 2s are 6. So how many dinitrogens you will get? 3 dinitrogens, right? And the leftover is just barium. This is another preparation of dinitrogen. 3 preparations of dinitrogen we have. One is from ammonium chloride, next is from ammonium dichromate, and next is barium azide. Now once preparation is over, what we have to see is its properties. That means how can you utilize or use dinitrogen to get different products. That heading is called as properties of dinitrogen. What is the first property of dinitrogen? Is it combines with metals to form not the azides but nitride. Okay. So which metals combines? Lithium metal can combine with dinitrogen. Just now what we have seen was azide, in which N3 is present as the formula, right? But the next type of compound is nitride, in which just a single nitrogen, lithium nitride. Lithium nitride is formed. This is having what type of balancing? On just one nitride, on nitride you will get oxidation state of -3. Only one nitrogen on which -3 is present. There 3 nitrogens on which -1 was present. Both are opposite. You have to not get confused. That was azide and this is nitride. If minus charge is -3, that means plus charge should be +3. To get +3 charge, you need how many lithiums? 2. This is lithium nitride. When can you get lithium nitride? If you take 6 lithiums, you will get lithium nitride. What else? Another metals also can combine. Magnesium. From first group we have taken lithium as an example. From second group also they can form nitride. From second group which element shall we take? Let us take magnesium. Same way even magnesium also can combine with nitrogen to form magnesium nitride. On magnesium what will be the oxidation state? +2. On nitrogen what will be the oxidation state? -3. Right? How can you make both of them equal? Into 3 into 2. Right? So take 3 times magnesium and 2 times nitrogen. This is the formula for Mg3N2, which is, this is lithium nitride and this is magnesium nitride. With lithium we have prepared nitride, with magnesium we have prepared nitride. Any other element also can form nitride. The next elements are, the next type of metals are not there, right? So S block element only should be taken as an example. Next property of dinitrogen is in preparation of ammonia only. Dinitrogen is used in the preparation of ammonia, that too in equilibrium reaction, which is reversible, to give you what? Ammonia. How to balance that ammonia? In dinitrogen there are 2 nitrogens, but here only 1, so I will take 2 dinitrogens. 2 3s are 6, that means I have to take 3 here. So is it balanced now? Right. What process this is called as? This is called as Haber's process for the preparation of ammonia from dinitrogen and dihydrogen. This reaction is studied under the process called as Haber's process for the manufacturing of ammonia. In the exam it's very important that they ask, write about Haber's process for the manufacturing of ammonia. That's it. No one will ask you for this formula what will be the reaction. General question is Haber's process for manufacturing of ammonia. In this process the reaction is under equilibrium, right? I have written both forward arrow and backward arrow. That means if you don't maintain the conditions properly, the reaction becomes reversible. So whatever product you got will be converted back into the reactant, which is nothing but reversible reaction. So you have to be very quick in practicing these equations. Okay. Now let us look at the next compound. What was the next compound of nitrogen? Ammonia itself. How can you prepare ammonia? By this process only. In detail we will study now.